Hi everyone, I'm Shadab and I work as senior associate at I mean as a for MLOps at the math company. If you want to connect with me on LinkedIn or Twitter, you can go to this handle and we can connect. Today I'm going to talk about MLOps using VertexAI. As a data scientist or as an ML engineer, you would have been working on training multiple models. But when it comes to production level work, there's a lot of other things to do, monitor and handle. Whether we talk about monitoring, scalability, logging, data versioning, uh, it's not very easy to integrate each of the components and monitor the stuffs. So my session will be focused on MLOps end-to-end pipeline and how Vertex AI can help us with that. Okay. So before moving ahead, what is machine learning? Can anyone answer that? You can type your answer in the chat, and maybe I can. Let's start from here itself. Okay. So machine learning is basically we make use of some data set and we try to train the machine on that data using some algorithm so that it can make future forecasting or prediction. There are different other use cases as well. So it is an application of AI, right, where we make use of algorithms and data to make the machine learn the pattern and make forecast or prediction for the future test data. So it will automatically analyze and make decision based on whatever pattern it learns without we manually go and intervene over there. So there are different types of machine learning: supervised, unsupervised, reinforcement. So we are uh, in depth about learning. Instead, we will just have an overview of machine learning. Then we will start with Vertex AI. So if I talk about supervised learning, right, there are two types of supervised learning as well: classification and regression. Just to give you an overview of uh, so if you have to classify a certain problem in one or two classes, I mean, then you have to predict whether a particular object or a particular test value belong to class A or class B. That will be considered as classification problem where you're trying to differentiate two different entity uh, based on the pattern machine learn, right? And similarly, we have a problem where we try to predict the continuous values. For example, if I talk about stock price prediction, or if I talk about uh, pricing of products, right? So retail companies they based on different input parameters, they try to understand how much pricing should I keep for this particular product, or if I talk about stock trading and all, then based on the past intraday trading data and all, people try to forecast like at different level of interval what is my next forecasting value is going to be. So these kind of problems will be counted as regression problem, right? So similarly, if we talk about few more examples for classification, like if you have to classify colors, like whether it is red, you have to classify, or if you have to make prediction whether it will rain today or not, or you have to classify different animals whether it is a cat, dog, or tiger. So this kind of problem will be considered as where we have the output variable as a category and we will have certain input parameters for that. I hope everyone is clear till here. If you have any question, please ping in the chat. Maybe at the end of the session or in the middle of the session when I go back and check there, we will take it up. Similarly, we have regression problem, like predict value of a stock or price of house in a city. So if we have a output variable which is continuous in nature. Continuous in nature, it will be numerical and it can have any value, a real value basically. So the problems with traditional way for building ML model is like we need very good machine, like your own laptop for training the model, and if you're building model with 1 TB, 2 TB of data like that, if you're going to handle the normal hardware which we have, the laptop, even though if you're using gaming laptops also, right, it becomes quite difficult to train such heavy models or handle such a huge data set on a local machine basically, right? And it take hours also. So there is a trade-off of time and configuration both if you are running something locally. And when next after training the model, we are not going to leave it on a local machine, right? We need to deploy that somewhere, and we don't know how much load and all we are going to get. So we have to define the scalability policy, how we are going to scale the policy based on the load we are going to get for that model, right? And we need some ML engineer expertise who can write the code for handling all these, right? To build efficient model, to deploy and scale the model, to make the training faster, to keep log of each and everything. So these are the certain problem with traditional way of building ML models. If you are doing it locally, or even though if you're not using some integrated components like for model monitoring, if you're not using ML flow or for logging artifacts, right? If you're not making use of different other inbuilt services by provided by different cloud, not just Google Cloud, so the job becomes quite difficult, and so much manual if work we have to do. Even if you're making use of cloud services like compute engine and all, right? You have to make sure whatever resources we are spinning up, whether after spinning up it has been turned off or not after the usage, what configuration of machine should I spin up and all that. So there are different number of problems which we can run into. So if I talk about an overview of like MLOps life cycle, how it looks like, right? So we have a source for raw data from where we pick the data, like training data you can see here. And based on the raw data we get, we train the models, we experiment with different algorithms, different features, we do feature engineering and all, we explore the data. And once we are done with this step, after that, we go for the checking the threshold, like based on certain metrics. If those criteria will be fulfilled, then we will deploy our model to the production. So when it comes to the production, right, at the production also we have to monitor the performance of the model, and we have to perform certain testing and all, and we have to make sure the model has been deployed properly in the runtime environment. And if a new version is coming, how we are going to archive the previous version and deploy the new version, and on what logic the model retraining is going to happen. So we need to monitor for data drift, model drift. We need to monitor for by model drift we mean model performance. Once the model has been trained, it's not like the performance of the model is going to remain the same for years or for months. Performance, it's more likely that the performance of the model will decay over time. And if you're not monitoring the performance of the model over time, then the chances are very 7 months, the prediction which our model will be making will be not very relevant, or it will be giving wrong inferences over there. Right, so we need to do the continuous monitoring, then build the CI/CD pipeline so that as our data scientists are making some update to the code or modifying some algorithm, right, the pipeline should be auto-triggered and new model should be deployed. So for that, we have CI/CD pipeline. Verification and testing happens at this stage. We need to think of deployment strategies and all that. So this is just an overview. There's a lot more which goes behind. Like for training data, you have to maintain the feature system. So from where different models will be consuming different feature set for training the model, right? And you will be doing the data versioning as well for whatever input raw data you will be getting or whatever feature store you are creating, so that at later point if you have to reproduce any of the experiments, you have all the things, all the logs, all the data in place, and reproducibility becomes easier over there. And why do we need to reproduce? Because suppose one today I have trained a model, and I'm using a model from which was being trained 4 or 5 months back, and I'm observing something, some anomalies I'm observing over there, right? So if I have to find out what is the cause of those anomalies which we have not observed or which we didn't notice from last few months, then if we don't have data log, or if we don't have the parameter log and details of the whole experiment what was being used to produce that model, we will not be able to inference or reach to the conclusion or reach to the root cause of the problem, right? Or to find the answer of our questions. So if we have everything in log, we can just pass in like for that model version, what was the data version which was being used. We can just extract that particular data from the data repository, and we can retrain the model. We can just explore the data over there to look at data stats, uh, because of which any bias or some anomalies has been introduced to the model. So this is an overview of MLOps life cycle. So if you have to tackle all this, right, how we can do that? So there's a uh, you can say there's a platform being provided by Google Cloud, VertexAI, using which we can tackle all this. We have several inbuilt components and the whole ML ops operation, or you can, if in different terms I talk about, right, end-to-end deployment of your ML project, whether it is normal classification or regression problem, or it is a computer vision problem or NLP problem, everything can be handled on Vertex AI end to end. And we are going to explore the platform as well, like how it looks like and what all features we have, right? So using Vertex AI, we can train the models without coding also. We have, I mean, with minimal expertise, we just need over there. We have a unified UI, UI using which you can design your own ML workflow, and you can manage the models also over there. And there are several pre-trained APIs configured with Vertex AI, like Vision API, Video API, Natural Language, and many more, which we can enable and make use of based on our project need. So if I talk about certain kind of ML or deep learning problems, right, which can be handled over Vertex AI. It's like if it in image we can handle classification or object detection problem. If I talk about tabular data, then regression or classification problem or forecasting problem we can handle, right? If I talk about text data, then text classification, entity extraction, sentiment analysis, all these kind of use cases can be solved over Vertex AI. Video again, classification and action recognition can be taken care of. So, in today, right, in today's webinar, we are going to look at tabular data. We will walk through how the things are happening, and we will see what next we need to do. So, Vertex AI tables, basically this helps us in build and deploy machine learning model on structured data. So we don't need to code or anything over there, and we don't even need to be expertise in machine learning. Most of the components are pre-configured, and it's just like select whatever you want to do and you can perform the action over there. So they have auto ML capabilities as well, which you can utilize if you don't have much experience with ML or writing the code. Go and utilize their auto ML components, and you can build your project or POC over there. So few of the example problem statement, if we talk about, right, we can consider if you have to predict the price of house, or you have to predict whether the person is going to be diabetic or not. If suppose if there's a credit card data, then and there's some bank who is planning to give new credit cards or loan to a customer, then based on their credit card history, they can classify the customers into good or bad. Or again, like product pricing, if I talk about, so mobile phone price range based on its features, RAM, battery, camera, processor, and all. Right. So these were the certain problem statement which you can think of, and Vertex AI is not just limited to this. At production level, you can think of, right. It can be scaled and deployed and Vertex AI. Next, if I talk about Vertex pipeline and Kubeflow, right? So what makes Vertex AI more useful over there? So earlier you see, right, how the data scientist job looks like. Scientists was dependent on data engineers to get the data, raw data. So it was the like responsibility of data engineers to build the ETL pipeline, process the data, do certain sort of different sources. From different sources they were pulling the raw data, and then they were dumping that raw data to some cloud storage or to some cloud services like BigQuery or RDS. If they are using, then they dump to RDS relational databases. And if or some companies used to dump the data into the cloud storage as well, like Google Cloud Storage we have, right? So all the process steps of pulling the data or ETL pipeline was dependent on data engineers. And as a data scientist, once he was getting the data at the destination after the ETL pipeline has been completed, then they used to go write the code to read the data from those cloud storage of using BigQuery, and then do the EDA, train the model and all. Then after training the model, it was not easy for them to put that model in the production. And if you work, so there are different scenarios which we are going to discuss about, and then we will talk about this slide. So that was one problem. Okay. Another thing was, as a data scientist, if you have trained the model, and if you're working in a team, how you will share your experiments with your team members, right? It was not that was another challenge, because if the files which are getting generated or the insights which are getting produced from your work or from your experiment is very huge, it was not very easy to share. If you're sharing also, the tracking becomes the tracking becomes a bit problematic over there, right? So how do you know, like, who has run which experiment, what stage a particular data science project is on, right? And what sort of metrics we are getting. Suppose two data scientists are working and one is using XGBoost, one is using random forest, and if you want to make the comparison for both of their work, right, how we can do that. So these things are a bit complex, and after experimentation stage, if you have to move further and deploy those ML pipeline or those model, then they have to think of how Airflow or some those kind of tools they need to use. They have to build a CI/CD pipeline so that model training occurs at a particular interval of time. They have to think of resources where they're going to deploy the model, like if they're going to use compute engine, if they're going to use compute engine and all, what kind of environment they need. So environment handling was another challenge over there, right? So like that, there are different things. So then Kubernetes came, so people started dockerizing their solutions and putting that in the production with the help of microservices, Kubernetes architecture. But again, managing Kubernetes clusters was also like that also needed a huge amount of effort. So on top of Kubernetes, Kubeflow was built, which can be called just as a component, and there are several pre-trained images. So Kubeflow is nothing but a pre-built customized container only for our work. You can build your custom containers as well, in which we just call this component as a decorator at the top of the function wherever we need to make use of that, and you just start using that. So we don't have to worry much about creating writing the Docker file or thinking of like what Docker image I really need to create, or thinking of the dependencies and environments which we need to create in those Docker images. So all those things were abstracted using Kubeflow. So Vertex AI is like making use of Kubeflow and TensorFlow extended. So Kubeflow runs on top of Kubernetes, and it is a machine learning toolkit. And the ingestion of one component to the another component also became uh, easier with the use of Kubeflow. So we don't have to worry much about dumping and reading the data, or dumping and reading the artifacts from different containers, like how the uh, connection or interaction we are going to build between the different containers. Instead, they can just focus on their work, their algorithm, their insights, and these uh, like MLOps or DevOps thing can be abstracted by using these kind of tools. Okay. So using a Vertex AI pipeline, we can make use of Kubeflow or TensorFlow extended. We can run our pipeline, and we can deploy that on a serverless component. So these whole pipeline run as a serverless architecture. And the benefit of serverless architecture, if many of you don't know, is the resources will be spent up only for the time we are using it. After that, it will be auto destroyed. So we don't have to manage the resources which we need to run our pipelines over there. Okay, so that helps us in saving the cost. So cost will be optimized over here, and the resources will also not be up and running if we don't need that, right? It will be just up and running for the time our pipeline is running. Once the pipeline run is complete, it will destroy all the resources which are being spent. So to run Kubeflow pipeline, right, we have a Kubeflow pipeline SDK which we need to install. And right now, what the version which we are using of Kubeflow pipeline is V2, and from that you can import different modules like pipeline, component, and compiler. We will look at the code of all these. So if I talk about component, right? So if component, you can think of a box which is just defined for performing specific task. So if I talk about data science life cycle, right, we have different stages in data science, like data preparation, then model training, model evaluation, model deployment. Like these are the four main components, right? After that, there are different other things which needs to be taken care of, but these are four. So you can define each of your steps in different components. Like you can define one step for data preparation, you can define one step for data for model training, you can define one step for model evaluation and another step for model deployment. And all the interaction between these Kubeflow component will be happening automatically with the help of input and output parameter. And if you call like this with using this decorator at the rate component, it will automatically spin up one function in one component separately. Okay. So whatever input will be generated from one component that can be passed to the another component automatically. And you can spin parallel components as well based on your requirement. So it's not like everything is going to be done sequentially. Suppose you have prepared your data house like feature store and you want to build multiple models in parallel to save time. And so each of these models will have some logic for the input data which they will take and filter out, and there will be multiple components pinned up parallelly, and model training will be happening in parallel for different parameters. So that kind of thing is also possible using Kubeflow and VertexAl. So all this flow is considered as pipeline. So in pipeline, like we call out different components, whatever we have defined. So it will execute in the order in which we call. And for pipeline also, we have certain input parameter which we can define, and that will be passed as the input to whatever component we are calling in here, right? So you can see that concat was my one component in which we are passing AB, and whatever output I am getting from this task from this component, I am passing that to my next component reverse. So you can see that concat task dot output will take the input as the output of this previous component over here. Similarly, once we have defined the pipeline as well, the pipeline is defined using the at the rate pipeline decorator over here. And after that, we compile our pipeline. So when we compile our pipeline, that creates a JSON file which will have all the steps defined and whatever we are doing. So this JSON file is basically used for spinning up the pipeline on Vertex AI. So whatever pipeline we create, right, for our machine learning project, that pipeline will get converted to the JSON file, and this JSON file you can consider as all the configuration, all the settings, all the code will be compiled in this single pipeline file. So this example, whatever we have seen, right, is a very simple function call we have made over here just to understand the flow of Vertex AI. Let me take you to the UI as well. So this is how your Vertex AI dashboard looks like. Okay. And in this you can see different parameters. We have workbench, pipelines, training, experiments, metadata, model registry, prediction, and matching engine. So when we work in production, right, there's a lot of thing we need to keep track of. So whatever pipeline component we saw, right, that we can track by going into the pipelines. Workbench will spin up a compute machine on which Jupyter Lab will be deployed, and you can open that Jupyter Lab environment in a new tab. So it will be your Jupyter Notebook environment where you can write your code and play around. Okay. Another thing is you can stop. You should stop your instance if you're not using, because you will be getting billed for that. This is your dashboard where you can get the overview of like which experiment was run recently, what components you have used recently, and all. So this is a user managed notebooks. If I go to pipeline, you can get the history of all the pipeline and whatever we have executed. So all these can be executed over here. If you go to feature store, so this will be your repository where you train your where you process your data and create the feature store. Okay, this is your data sets where you can create your data set of your own, or you can register your data set from your notebook also. So this can handle tabular data here. You can do the labeling task also under the data tab. So if you have some labeling task and all, you can create and handle that too. So that was related. These features are related to the data component. Okay. If I talk about model, so you can track the training pipelines over here. So if you are what if it is custom or auto ML, whatever region you have trained, you can select that region and you can see your pipeline. If you have done any, then those custom jobs can also be trained from this UI itself. I'm showing you right now. I'm showing you through the UI, but all these things can be uh, handled via the Vertex AI SDK as well. So we will cover a few of the components using the code also, so that you get an idea of what Vertex AI is capable. Based on to that knowledge, you can build on top of it. Hyperparameter tuning job, if you have to define any right to tune your model for the best efficiency, those jobs also you can define in the Vertex AI. You can define the experiments, and under the experiment you can track different pipeline. And so suppose one experiment I have defined name, experiment name you can consider as a project, and for that project, whatever pipeline I will run, right, all those experiments can be tracked over here, and the parameters and metrics for that also can be tracked for a particular experiment for different runs. So here, this for this experiment, I ran my pipeline just for one time. So for that, I just logged MAE value as the parameter. So that was being logged over here, and different other input parameter you can observe over here. So like that, you can select multiple pipelines and you can do the comparison over TensorBoard as well. If you integrate your TensorBoard with your custom model training or auto ML training part, then you can also log the metadata of the model, whatever you are training. So right now, like I have not log much in detail, but like whatever KPI output you're getting, if you're deploying that model to certain endpoint, then Vertex endpoint will get created. Train test data set where it's getting logged, model where you're logging, Vertex model where it is being stored, right? All these metadata can also be logged and tracked from here. Then we have model registry. Whatever model you deploy, right, that you can handle from here. You can click on these three dots, and you can either delete the model, deploy to endpoint, whatever actions you want to perform here. From here, you can do that. Then we have endpoints. Endpoint basically act as a API service where at the backend you deploy the model from the model registry to a particular endpoint, and you have to make, right, you can hit this endpoint and make the instance prediction, or you can even make the batch prediction also. So that's up to you how you want to over here. So these are the certain components and features of Vertex AI. So before moving ahead, I will just check out the questions if we have any. Okay, do we have any question, Yen or Arker?
Giving any questions right now?
Okay, great. Then I will proceed further. Okay, so these are certain features and components. These all you can handle using the Vertex CI SDK as well. So let's get back to Workbench. So when I open the Jupyter Lab, it will open a Jupyter Lab environment, and this will give you an environment of Jupyter Notebook over here. So before running our pipeline and defining the components and all, right, I need to enable certain APIs, container registry, AI platform, cloud build, cloud function, and compute. Okay, if these APIs are enabled, then uh, I mean, once these are being done, you can these packages I already have pre-installed. I'm not going to install it again. So I'm going to import certain packages which I need, and before that, whatever experiment I run, right, that will be getting stored. I mean, right now, whatever artifact model in dataset I'm generating or splitting in train and test, right? Everything I'm logging on Cloud Bucket. So you need to define the bucket name and the path also where you are going to store that to. And after that, I'm going to import the packages. You can see, right, DSL is one module which we are importing, and from DSL we are importing artifact dataset. So artifact will be responsible for logging all the different artifacts, whatever we want to store. Dataset, we will have, if you want to log dataset, whether it is complete data or after splitting into train and test, you can do that. Input will act as a to pass the input to each of these components function here, and output will be for getting the output, uh, logging the output from any of these functions. Model again to store the model. Yeah. Metrics for storing the metrics of the model. Classification metrics, if you're generating any, we can log that too. Component is a decorator which we will be defining over each function call, over each function, so that each of these function will be deployed to individual components. And then we will make use of output path and input path as well to define some paths of Google Cloud Storage to log or read from that. Okay, and then we're importing the pipeline jobs to build the pipeline and run it. So this is the function I have defined for getting the data. Okay, so you can, so since I'm not going to read the data from any source, instead I'm making use of a path on Google Cloud Storage. So this path I will be passing while calling this function in my pipeline. And after loading the data, right, I'm doing certain pre-processing step. I'm splitting the data into test and train, and I'm logging that to the particular path using dataset train and test like input output component, whatever I imported from the Kubeflow package. So these will be logged. The train and test dataset will be stored at a particular location on Google Cloud Storage for this pipeline then when I will execute this. And similarly, I'm logging the metrics as well. In metrics, I'm not doing much, just I'm logging the like number of rows for train dataset and number of rows for test dataset. Similarly, I have defined a train model component as well, in which I am training a simple random forest classifier model. And after training the model, I am dumping that model or pickling that model to a particular location on Google Cloud. So how this path is coming is output model, right? So this output model pick model.path, it dump directly to that path on Google Cloud Storage using the Kubeflow component. You see, right? I don't have to define or handle these paths manually over here. Each of these things has been taken care of automatically using the inbuilt components or inbuilt functions over here. Similarly, for reading the dataset also, right? Whatever dataset I get from this component, I'm basically the train dataset I'm passing to this that component too. So while calling this, I will pass in the dataset underscore train output from this pipeline, from this component to this component for training the model. So I don't have to worry about how data flow is happening across different components as well. I know the name, and just based on the name, I'm passing the input from one I'm passing the output of one component as the input to the other component. Similarly, I have defined evaluation function as well. So before deploying that model in real-time production environment, right? It's like we need to do certain model monitoring or model checks. Like if it is beyond certain, the accuracy is beyond certain threshold, ROC curve is beyond certain value, right? And also these metrics we monitor, if those checks are being passed, then only we will put the model to the production, or else we don't deploy the model to the production. These logics you can custom build of your own, but these things can also be taken care of. So I have defined the threshold function which I'm calling Based on the results returns from that threshold function, I will be evaluating, I'm calculating certain metrics over here after loading the model. And then based on that, I'm logging and then I'm calling that threshold function. If it returns true, then my model will be deployed. If it returns false, this deploy component will not be called. And if I talk about while calling the component, right? So for each of the component, you can again take as the this function which is going to run on a Docker image. So base image, you can see here I have defined at Python 3.9 base image of Docker I'm using. You can define scikit-learn base image or XGBoost base image or TensorFlow base image. So Vertex AI has certain registered custom images of Vertex AI which you can make use of. And on top of those those images, it's not necessary we will get all the packages or modules installed, right? So using packages to install parameter, right? You can pass in the list of the packages to be installed as well, and you can define the output component file which will generate a YML file for your code. So all these YML file which you can see here, right? Let's say if I generate get wine data. So this is how your YML file look like. So this is similar to the Docker file. If you have to go and write this kind of file by your own, how much time it's going to take to deploy a single component on in production, right? But this has been auto taken care by the Vertex AI. So this YML file is getting auto generated just by the call of this component decorator over the function. So name, output name, input name, container, image, command which needs to be executed, your code, everything has been defined over here. So once if the threshold will pass, then the deployment will happen, and you will choose the machine type on which you want to deploy, and you can define the traffic split as well, and even you can do the model versioning also. Suppose if for the first run your model was being trained for the first time, then if next time you're going to train, your model version will be 2. Like that, you can keep the track of that as well. So once all those components you have defined, right, you can create the pipeline, and in pipeline you can define the pipeline route path and the name of the job which will be useful for uh, pulling any data for this particular pipeline run. So now see, I'm passing certain input parameters, right? Like URL of the dataset, project ID, region, display name, API endpoint to which it should be deployed, threshold, like I'm evaluating my model based on my ROC value. If my value will be lesser than or greater than this, then only I'm going to deploy, or else I will not. Then what is the base image which I'm choosing for deploying the model, for deploying this pipeline, right? So all these things I have defined over here. And you can see here, right, in the sequential order, I'm calling each of these components, load data pipe component, train component, evaluation component, and after that, deployment component. So these will be spinning up in sequence, and the output of one is being passed to the input of the another component. So all these abstraction has been handled over here. Once you have defined your pipeline function, we are going to compile our pipeline, which will generate a JSON file. Okay, and this JSON file we will be passing to start pipeline. We will submit this pipeline, and you will get a URI, which will take you to the pipeline. Then so let's see that too. So I have started a pipeline, and this will take you to this page here where you will be able to track the steps of your pipeline here. So if you come over here on this page, it's just loading right now. Yeah, so you can see, right, all components have been created, and you can see what is happening at what stage. So most of, since I have put cache is equal to true, right, if there are no changes components, it will not rerun the component. So this is another benefit of using Vertex AI and Kubeflow together is if at a particular step you have not done the changes. Suppose for example you have done the changes at the evaluation step only, right? Then in that case only your pipeline run will start from this particular component and previous component will not be running again. So this will again add up to the cost saving and optimization of your resources and reduction in the pipeline run. So suppose as a data scientist, it's not like we are going to make change code flow, right? We just make changes to a particular function or to a particular step in our data science project. So it will just start the run from there only. So that's another way and benefit of if you modularize your code in different functions and make it run on different components using the Kubeflow pipeline. So once this evaluation step will be true, it will deploy that. Before that, let's see the output and artifacts, how we can track that. So if you click on this component, on the UI also, you can see what was the input parameter and whatever output metrics we are logging, test and train, you can see over here. Once, if you want to see the logs and job, you can click on any of these and you will be able to track the logs and job as well. If you want to expand the artifact, you just click on that. So your artifacts will be also expanded. So from first component itself, we were splitting the data into train and test, right? Train was being passed to the training pipe component and test was passed to the evaluation component, and we are logging certain output as well, output metrics basically. So you can click on each of these artifact sub-component as well and see what was happened. So if you click on view lineage, right, so this will give you a graph of your whole pipeline, like how and what is being getting logged from where, how your pipeline is running. So let it load. So this is how our like it looks like for this pipeline run. Okay, so all these functionalities available on the Vertex AI. So similarly, this dataset train was passed to the train vine, and the model was being stored at this location on Google Cloud Storage. So everything has been monitored over here. So once this will be done, right? Let me open this one over here. So we have not deployed the model, for example, at this stage. We have just removed that because API endpoint creation and all, it will take few minutes to cover up. If your model has been deployed, right, in the endpoint, you will see endpoint will be generated over here, and in model registry, if you will go, whatever model will be in the production, you can click on that and you can see whether it has been uh, generated and deployed or not from the deployment status. Apart from that, you can even do the model monitoring as well. So when you will go to endpoint or when you will come to model registry, right? I mean, right now I have not enabled that. I just tried to keep the demo short. But if you go to the endpoint and when you will open the endpoint and see the model deployed to that particular endpoint, right? You can see whether model has been model monitoring enabled or not. So these were certain things which I wanted to discuss. And a bit more of theoretical. So Vertex AI provides GPU machines as well. So in your project, suppose if you need some high computing machines, then you can go for those kind of machines as well. And component types, again, you can make use of either function-based component or container-based component. And container-based component will be flexible to run in any programming languages. And with function-based component, what we were doing, we can just try. Another thing is you can predefine the components. So we have already different steps. So you can make use of batch prediction or terminal training, whatever you want. So these are certain predefined components. Apart from that, if you want to define your own component, you can do that. Parameter passing and output we have already seen. Artifacts, as I discussed, so these are the symbols for different artifacts: data set, model, metric, and visualization. These artifacts can be generated, passed in, or logged from a particular component. So Vertex API, and we need to enable the Vertex AI pipeline API to run this job, and the requirement to run this pipeline on Kubeflow component, we need the Kubeflow package over here. So there are different methods which you can make use of. You can cancel a pipeline by calling the cancel method. You can create the pipeline. You can delete the pipeline, get the pipeline, or list the pipeline for the particular location. So these are the certain inbuilt methods which you can make use of while working on any of the project. You can so after doing all these, right? Suppose if you don't want to push your code to the GitHub and all, instead you want to schedule from the notebook the cloud scheduler service available on Google Cloud, right? You can call the function with the API client call, and you can set a cron job over here with the path of the pipeline JSON, which gets generated from the after compiling your pipeline. You can specify that path, and this pipeline will be triggering after every particular interval of time, whatever you define. So scheduling pipelines also becomes easy over here. And if you want to do the manual run, then either you can submit or call the run method. So this will again run the pipeline. So demo we've already seen. So that's it from my side. I think we're on time, 10 minutes earlier. So now if you have any questions, I can take that up or we can discuss. If no, I will end up the session over here. Do we have any questions, Ian? We are good.
Yes, it's loud.
Sure. So since we have 10 minutes left, right, let me cover up a few more things of Vertex. So when you work on Vertex AI, right, it's always recommended that you have proper permission. Ask your if you're not aware of the permissions and all what you need. So ask your cloud resource manager. He can look at the permissions for whatever you need to do this job, and you can make use of. Another thing is, let me take you to the GitHub repo. So if you want to build your CI/CD pipeline also, right, uh, for whatever project you're working on. So using GitHub Actions, it becomes very easy pipeline and uh, run it basically. So if I take you to the settings, and here if you on GitHub we have GitHub Actions option available, right? So if you click on GitHub Actions here,
Hello, we received a question.
I will just take that up.
Yeah, someone
And okay, so you can configure your GitHub Actions from here as well. And another thing is secrets and all can be managed from GitHub repository itself. So here you can see I have defined action secrets, whatever I want. Code expresses, I didn't need it, so I have not defined the code expresses secret. Depend bot also, I think I didn't needed that, so that's also not defined over here. Apart from that, you can deploy the keys if there are any which needs to be utilized in your code. So all these things can also be handled. Basically, CI/CD pipeline using GitHub Actions is a bit easier in comparison to the other two. So that's one thing. If I go to the action tab here, right? So here you can see when all I have triggered this pipeline. You can look at the workflow run, right? So all these things you can check and monitor from here. So if I take you to a particular run, like for example, this was my run. So what were the changes? As some changes was being done on my code, right, and I pushed to this repo, the pipeline was auto-triggered. So it has been configured in such a way. So there are two workflows. I mean, this is the Python application workflow which we have defined. So if I take you to the CI/CD YML file, so this is the file which we have stored in the .github workflow folder, where we have defined all the steps and actions needs to be taken to make this pipeline run. So you can see that with just few lines of code, even we have integrated our CI/CD pipeline with the GitHub and Vertex AI. So this whole solves a lot of complexity for the data scientists to build their end-to-end MLOps project. Yeah. So for long-term task, what is the question?
Yeah, to ask.
Which can you iterate that? I cannot see it.
Yes, I did during check.
Hello. Question is available in advanced stage. You are currently looking at.
Uh, can you please repeat if there is a state change? Uh, I was not able to understand. Can you please type in the chat if possible?
There's a chat area on your right. There's
Yeah.
a stage. Yes, there
Okay,
is.
stage I have to go. Yeah, I got it. So is AWS great? So AWS itself is a whole cloud provider, and Google Cloud is another cloud provider. Cloud provider, we have multiple services, not just one. So AWS SageMaker, if you have heard of, so SageMaker is being used for handling end-to-end data science projects. Similarly, AWS SageMaker is not the only service using which we can build the production level code, right? We need several other services as well. If you're going to deploy your solution and pipeline and divide your code into different stages, you are going to have multiple environments like build and development and production environment. So you're going to make use of code commit, code build, doc containers you're going to use on AWS, right? Then pipelines. So AWS itself is of n number of services, out of which you can make use of the services which you need to run your ML ops work or ML ops pipeline. And you need to define and decide on that architecture. Maybe for everyone, model retraining is not required. So in that case, they will not consider that logic. Similarly, for everyone, data versioning or feature store integration is not required. So they will think that way. Vertex AI is a separate service, a platform service, you can say, which is provided by Google Cloud, which abstract most of the complexity, and it provides a simple user interface and SDK as well, using which we can build end-to-end ML and because so that the experimentation, tracking, logging, monitoring, reproducibility, explainability, everything becomes easier. We don't have to and we don't need to sit and end up writing thousands of lines of code or and then later get lost in like what I have written. If I have to make a small changes to a particular thing, we have to go through the whole code and try to understand and figure out like where was that particular line being written and how to handle that change. So it has been provided using Qflow component on Vertex AI so that this complexity can be reduced and prototyping or production time to put a project in production becomes shorter and easier as well by adapting certain best practices in the industry. Um, did I answer your question or do you have something else to ask? Okay, I think we are good. So, all right, thanks, Jean and organizers for providing me the opportunity to talk here for DevFest, right? Especially Arthur, like he was communicating with me. I hope you had some good learning about Vertex AI. If you have any questions or if you want to get in touch for similar workshop, like this was very brief overview of Vertex AI. many things I was not able to cover up and demonstrate in detail. So if you're looking for similar sort of workshops or tech talks or hands-on demo, you can reach out to me. So I will share my LinkedIn and Twitter handles. You can just go over there, and with this username Tech with Shadab, you can find me on any of the platform: Twitter, Instagram, LinkedIn, GitHub, anywhere. And yeah, thanks everyone for attending the session.
Yes, we are honored to have you at this event. Thank you, Mr. Shadab, for your excellent presentation.
Thank you. Thanks. Bye.